So it would be infinite.
There'd be an infinite number of solutions, correct. There would be an infinite number of solutions, that's correct. So if a solution system leads to a true statement, the system has blank equations. If solving a system leads to a true statement just as 0, 0, the system has blank equations. Oh, to answer this question, blank equations, what word can you put there?
Infinite.
No, that's infinite number of solutions. I didn't see the last word. What does it mean about the equations?
All of them.
The same. It's the same equation. If you end up with a true statement, it means you have the same equation written 2 different ways.
So is that 4?
That's 4. The same. So like basically it's asking this. If I have a line, everybody, if I have a line and I have another line that's on top of it,
They're all the same.
it's the same equation. It's the same equation. It has one equation. That's what you can say.
They're parallel. They don't touch, but it's the same.
No, they are. Excuse me. They are touching, so they're not. They're not. It's called the same line. It's just if you're solving, how many times are my arm intersected? It's the same arm. And then what's the point that we're most interested in? Intersection. That's right. This entire section is effectively summarized in the search for points of intersection. The graph of an equation is the visualization of all the points that make the statement true. So the blue is where all of the points that make that equation true. The red is where all of the points where that equation is true. So the point where they intersect is the point where both equations are true. The search for the point, and later in your math for points that make the system true, that make both, or sometimes 3. We'll get to that. So, for example, I might give you this linear system. It's a system of equations because there's more than one. The solution set of a linear system of equations consists of all ordered pairs that satisfy all the equations. How many equations do you have right here? 2. So if this is going to be a solution, it has to work in both of them. How do you check to see if they work in both? Substitute it in, right. So the first one, does 4 plus 2 equal 6? Does 16 minus 2 equal 14? So is this a solution? Yes, because it works in both. It works in both. That's not bad. Exactly, right. I gave you, I said, is this a solution? If I had said like 4, 7, does that work in either one of them? No. So is it a solution to that system? Could it work in one but not the other? Sure, but would it be a solution to the system? No, it has to work in both of them.
So a system is when there's a one that's the same at least one.
A system is more than one set of equations. That's what a system is. This is a system of equations because there's more than one equation. It's an equation because there's an equal sign there and there's an equal sign there. There are 2 different equations.
It's a solution.
Works in both. Correct. Now you can do it 2 different ways. Sometimes you might not be given the solution. You might be looking for that solution. What's one way you could find the point of intersection? Hint, hint, hint. What's one way? Graph them. Now that might be helpful, but what's one of the weaknesses to graphing for solutions? Yeah, Chris. It's not too accurate. Like unless you're hyper accurate, it might be really hard to find that point, right? You could. That is something we could do, and the calculator would be more accurate, right? But still, if you graph by hand, does it give you an idea of what the solution is? Yes. Sure. It might be a quick way to know, like, oh, the solution's around here. But we want a better way to do that, and that's what we're going to focus our attention on. So, for example, let's say we had this solution, right? This linear system. It's more than one line. We're looking for the point that works in both. How do you go about doing that? We've done it a couple times already. What do you do first? What do you mean set them to 0? Okay. Can you tell me more specific? Yeah.
Could you like single out the y?
Absolutely. So which y do you want? The y on the top or the y on the bottom? So what does y equal in this case? 5 what? 5 minus x, because you have to subtract x from both sides. And then what do you do with this 5 minus x record?
You would plug in into the y.
You take that and you plug it in right there. We know that y needs to be 5 minus x, so you plug it in right there, and you plug it in where y is, so it's going to be 2x minus, instead of y, what do we write? Equals 4. It stays 4.
Oh, actually that's
This is substitution. We did this a little bit. You've done it before, or maybe a lot before. Can you solve this? Yeah, it's a single equation, and it's going to be, what's next here? Plus x, because you distribute the negative. So you get 3x minus 5 is equal to 4. 3x equals 9, x equals what? Are you done? Why not? Yeah, you need to take this, plug it in there, you get y is equal to 5 minus 3, which is 2. So what do you got there? So the point would be 3, 2. Does that make sense on that one? So this method right here, what was this method called? Substitution. Substitution is super powerful, and you're going to do it a bunch in this class. A bunch in this class. So in terms of there are 3 different types of solutions. You could have 2 lines that intersect once. You could have 2 lines that never intersect. And then you could have 2 lines that are the same line. How many solutions are there for this system? 1. How many here? None. How many here? Infinite. Right, exactly. Exactly. What happens if you try to use substitution on a system that looks like this? You get something, but anybody know what you get? Yeah, you end up with something like 7 equals 4. If you try to find where 2 things intersect that don't intersect, it's a contradiction. You're looking for something that doesn't exist. So math is going to say, if you start with something broken, you're going to end with something like 7 equals 9. If you do a lot of proper work and you get 7 equals 9, something's wrong. They don't intersect. You were looking for it. So what do I mean? Let's do one. I think I have one. I'll make one up first. How about that? So how about this? X plus 2y equals 4. And how about this? Negative x, make it a little bit more interesting than that. How about negative 3x minus 6y equals negative 12? I've done this a lot. So let's solve this. If we wanted to solve this, what was the method we used before, Sarah? What was it called? Substitution. So we need to isolate something. You can isolate anything you want. What do you think the most easy thing to isolate would be? Yeah.
X.
In the
In the first.
Yeah. If you isolate x in the first one, you get x is equal to 4 minus 2y. And then you take this, and where do you truck it? You take this right here, and it goes to where x is. Exactly. So you end up with negative 3 times 4 minus 2y minus equals negative 12. Is how many variables are right there? 1. There's the same one twice, but it's one variable in one equation. So can we theoretically solve for y? Theoretically. Yeah, so let's try solving for it and see what happens here. You get negative 12 plus 6y minus 6y is equal to negative 12. Oh, look what happens here. That goes away. You go off with negative 12 is equal to negative 12. What does that mean? Same line. If you graph this, it's the same line. Can anybody tell me, you asked the question initially, how did I make this so I knew it was going to be the same line? I didn't do all this math in my head. Take a look at this.
Oh, you multiplied by 3.
I just multiplied by negative 3. See this? It's just a multiple. That's all I did. It's the same line. Can you write a line many different ways? Yeah, there's an infinite number of ways. If you end up with something like this, it means that you have the same line. It's the same equation, just written a little differently. Yes?
If you got it where like it was like a positive number equals like its opposite,
it would be parallel lines. If you do this kind of work and you got like negative 12 equals 7, that means they're parallel. Well, negative 12 equals 12. That's not true. So it means that what you started with was not true. So let's try this one. Solve that one for me right there. Go ahead. Great. So check your answer. What'd you get, Sadea? No, we didn't. What'd you get? No. We were just chilling. What'd you get? X is what?
X equals.
Yeah.
X equals to y equals 2.
Y equals 2. What does x equal?
I go at 4. There we go.
4, 2? Who agrees with 4, 2? You are popular today. Excellent. That theoretically you can follow for substitution. Solve one of the equations for either variable. Does it matter which one you solve for? No. So if you get to choose, which one should you choose?
Easier.
Easiest one. Substitute, solve, find the other value, and then what step do most people skip? The check. Check your answer. Check your answer. Please check your answer. I meant that the answer to the first one is 1, 5? Okay, so when you did the second one, there are lots of ways in which I'm seeing a lot of great work on the board. What I want to show you is the most straightforward way. There's lots of different paths that are correct. Let me show you the most straightforward way. When you look at that system of equations, what's the first emotional response that you have?
you can just
But when you
Fractions.
fractions.
Yeah.
So if you see fractions, what might you want to do first?
Not do it.
Get rid of it.
Run away! Eject to Bermuda, which might be a windy place to be right now, honestly. Yeah. Common denominator is a noun. Give me a verb. Give me a verb. And then do what?
Divide.
How about we just multiply everything by 6?
Exactly 6.
What's 6 times
Exactly
2/3?
what I said.
6 is an, I understand, 6 is a noun. I asked you what your emotional state was, that's why it was kind of funny.
2.
What's
4.
6 times 2/3 is 4, so it's 4x minus, what's negative a half of 6? 3y equals 7, and then just copy this. Look, we have the same exact thing, but what did I get rid of? Look, no fractions.
Chris, you're right.
Yeah.
Is your life a little easier now?
Plug it in, so works.
I'm not saying, I never said the other methods were wrong. I'm trying to say, here's an easy thing you can do to get rid of all those fractions. Now, what's your first step if you're going to use substitution? Isolate something, right? If it was me, I would isolate the y on the bottom. I would take this and put it on the other side. So I would turn this one into 3x minus 6 is equal to y. And then what do I do with this? I would plug it in right there.
That's really ugly.
I'm sorry, I'll pick something better here. I'll take this, and now what does it become? 4x, what does it become? 4x minus 3 times what? 3x minus 6 equals what? Equals what? 7. I'm just plugging it in. I'm not doing the math. All I did, what does y equal?
Y equals
This.
that.
And where did I plug it in?
Plug her into
Right
Y.
there. Now, how many equations do I now have?
One.
How many variables are in it? 1. Can I theoretically solve that? 4x minus 9x plus 18 is equal to 7. What's 4x minus 9x?
Plus 18.
Plus 18 equals 7. So negative 5x is equal to...
Negative 6.
What's 7 minus 18, everybody? Negative 11. So what does x equal? What does x equal? 11 over 5.
Wow.
2. Y is equal to 3 times
11 over
5 minus... So y is equal to 33 over 5 minus 6. We're not done because I want you to simplify it. How many? You need a common denominator. How many?
33 over 5 minus 30.
Minus 30 over 5 equals 3 over 5. So the answer to this would be 11 over 5, comma. Yes. Sometimes you will have to use fractions. Sarah, sit down.
I literally did.
This one. Don't do it. Just look. Stand up, Noah.
Just no.
No, just Noah.
Oh,
Just Noah.
just
Just Noah. Just Noah. Noah, if you're going to do that one, what do you notice? What's one structural thing you notice about that one? What's something that's nice about that one? Or you think is nice?
These solutions are 6 and negative 6. So they're opposite.
Yeah, they're opposites,
Yeah.
right? That's kind of neat. Here's something you're allowed to do. He's just pointing out that the number 6 is the opposite of negative 6. He's just saying that might be nice. He doesn't know why yet, but it might be nice. In this system, here's something you are allowed to do with any system. What's the golden rule of algebra? Do you remember what it is?
What you do to one side, you
Do to the other. If two things are equal, can you just add them to both sides? Sure. If you add 5 to one side, can you add 5 to the other? You have to, right? To keep the scales balanced. Here's another thing you are allowed to do. You're allowed to add equations. What's negative 6 plus 6? What's that equal to? 0. What's 3y plus negative 3y? 0y. What's 2x and 4x? So what does that mean x must be?
0.
0. X must be 0. X must be 0 because 6 times what is 0?
0.
So if you have x is 0, how do you solve for y? Into which one? Into which one?
You put X.
The first equation or the second equation? You can sit down. Exactly. It doesn't matter. So let's do the first one because it's positive. 2x plus 3y is equal to negative 6. But where do we plug it? Oh, 0 plus 3y is equal to negative 6. So y is equal to? So what's the answer? If I ask you for this, you need to state the answer as 0, comma. Does anybody know what this method is called that we used?
Yeah, I remember. I did.
We're adding equations, but we use something that's right here. They're going to call it the elimination method. What was the really nice thing that happened here that made it possible for us to use this method? Canceled out the what? The y's, yeah. This was really nice. It was cool that this came out to 0, but did it matter? No. This was the thing that had to happen. They had to obliterate each other. They had to obliterate each other. Now here's the thing. How often are you going to have perfectly opposite values like that?
Very rarely.
Really rarely, right? Unless you make it true. Let me show you what I mean. Do you see any opposites right there? No. Again, what is the golden rule of algebra? What you let me finish my sentence. What you do to the other. So what could we theoretically multiply the top one by? You want to multiply by 3? We can do that. That's fine. We'll multiply this one, and I'll get a better color so you can actually see it. 3. What should we multiply this one by? 2. If we do that multiplication, what does the top one become? Can someone else tell me what it's going to become? What is it?
15x minus 6y plus 12.
And what does the bottom one become? Someone else. Someone different. What do you get today?
4 plus 6y.
Yep. Equals. Now, why is this suddenly something that's really helpful?
I got this.
Yeah, go Gabby.
Because you can obliterate.
Yeah. By doing what?
Add them together.
We're adding them together. We cross them out because we're adding them together. So when we add these, what's 15x plus 4x?
19x.
Equals?
38.
So x is equal to? Does it matter which one we plug it into to get y? So how about 5 times 2 minus 2y equals 4? We're solving for y. Equals 4. So negative 2y is equal to negative 6. So what does y equal? Just 3. So if you state the answer, what's the answer going to be? 2, 3. So here's the thing with elimination. Even if you don't have opposite numbers for coefficients, can you make them? You chose 3 here because it was the coefficient here. The quickest way to do it, just flip these and multiply by them. Yeah, or a common denominator. Yeah. A common. As long as they obliterate, you can always simplify later. Yes.
Do you necessarily have to?
2. Ah, but then what do you get? 2x plus 6y is equal to what? 8. And then what do you get? Negative 2x minus 6y is equal to what? When you add them together, what do you get? 0 equals what? 5. Sorry, no, 0 equals 11. We're adding them. What's the problem? What's the problem? That's not a true statement. So these lines are what? Lines are parallel. They do not intersect. No intersection. There's no intersection. There's no intersection. What happens if you try to find something that doesn't exist? You're going to get a broken answer like this. You get a broken answer. Now I think, what do you multiply the top one by? How about 3 or negative 3? Well, okay, let's do 3 and see what happens. Sure, we can do 3 and see what happens. If you do 3, what do you get on top, Sadea?
6x
minus 3y is equal to what? And on the bottom you get 6x minus 3y is equal to what? 9. So if you can subtract, Noah said, can you? We asked that, can you subtract? Sure. If you subtract these, what do you get? Equals 0. Is that the same type of answer we got before? No. That's true. So what does this mean? Same line. It's the same line.
I just did something.
Well, now, Sadeh, what did you then do here? You can then subtract if you want to.
Yeah, I did that.
What's 14x minus 14x? 0.
Yeah.
What's negative 21 minus negative 4?
Negative 25.
No. Negative 21 minus negative 4. Negative 17y. And what's negative 56 minus 46? No. Negative 56 minus 46. Isolate y, what do you need to do? Yes, and if you do that out, anybody get it? 6.
Oh, yeah, that was a good one.
It's good, yeah. So are you done?
No, I didn't
No.
get that far, to be honest.
It's okay, but are you done at this point, kids?
No, you gotta plug that in.
Yeah, you got to plug it in. Let's plug it into the top one. So it's 2x minus 3 times 6 is equal to negative 8. So 2x minus 18 is equal to negative 8. So 2x is equal to what? 10. X is equal to 5. So the answer would be
6, 5.
5, 6. Because that's the X, that's the Y.
That's a